Hello everyone. Good evening all. Welcome to YouTube session 8. The second type of calculus. Previously we had discussed differential calculus. Now the present one is integral calculus. That is definite integrals or indefinite integrals. So before going to standard integrals, this is the definite integral definition. If f of x is continuous in closed interval a comma b. What is the meaning of geometrical interpretation of continuity? Graph of fx is continuous without breakings. That is, the graph can be drawn without breakings. That function f of x is called continuous. In closed interval a b, function is continuous means at every point between a and b, the function should satisfy the continuous definition at every point, and at a, the right hand limit of f of x should exist, and at b, the left hand limit should exist, and phi of x is an antiderivative of fx. Another name of integral is antiderivative. So integral is the antiderivative procedure. That is, integral f of x dx is equal to some x terms, that is phi of x plus c, where c is constant of integration. So this type of integration is called indefinite integral, which represents geometrically a curve, family of curves. For different values of c, you will be getting different curves. When that integration is bound between two standing lines, two vertical lines, that is x is equal to a and x is equal to b, the value of this integral a to b f of x dx is equal to phi of b minus phi of a. So in this indefinite integral answer phi of x, substitute x is equal to b, you will be getting phi of b, put minus, and then substitute x is equal to a in phi of x. You will be getting phi b minus phi a. So this is a definite value. So this is called definite integral. So the interpretation, whenever we need to find area under the curve f of x above x-axis between two vertical lines x is equal to a, x is equal to b, is given by this definite integral only. That is the application. So this is also called, some people, second fundamental theorem of integral calculus. Second fundamental theorem of integral calculus. Now let us see an example. Integral 0 to 1, 3x square dx. Actually, this is x square dx. Please ignore this 3. Consider x square only. Only x square. So this is fx. Integral x square dx is, you know, that x cube by 3 between the limit 0 to 1. So this x cube by 3 is phi of x. So phi of x is the integral, that is the antiderivative of fx. So substitute upper limit 1, you will be getting 1 by 3, and substitute lower limit 0. Before that put minus, so 0 by 3. So a is called lower limit, b is called upper limit. In the above, this fx is equal to d by dx of phi x. For example, d by dx of x cube by 3 is 1 by 3 into 3x square. So you will be getting finally this x square. Now result. If f of x is continuous on closed interval ab, then there is a problem. Some integrations, limits 1 to x or 0 to x, very tough integration. It is difficult to integrate. For such integration problems, if they ask derivative with respect to x, this result will be very much helpful to us. So outside derivative with respect to x, inside integration with respect to t, limit should be a to x. So the upper limit x is same as the independent variable of the derivative d by dx. So you will be getting the answer f of x. So this f of x is called integrand usually. So here the integrand is f of t. In that f of t, substitute t is equal to upper limit x. So the derivative integration got cancelled. Just substitute the upper limit x in place of t, you will be getting f of x. This is called fundamental theorem of integral calculus. Suppose the same type of result, instead of x, You will be having x square or sin x, e power x, any function of x, upper limit is v of x. In place of a, lower limit a constant, you will be having another function of x or constant. Let us denote by u of x. Now the limits are u of x to v of x. The same representation as above. Outside derivative with respect to x, inside integration. So how do you remember this answer? Just like limits procedure after integration done. Substitute upper limit v of x in place of t. You will be getting f of v of x. The outside is d by dx. So d by dx of upper limit, multiply this d by dx of upper limit. So first substitute upper limit in place of t, then multiplied by upper limit derivative, minus substitute lower limit u of x in place of t, then multiplied by d by dx of lower limit. Okay, where ux, vx are differentiable function. That's why there is d by dx. Now this question asked in 2018, direct statement. If f of x is continuous on closed interval AB, then there exists a number between a and b. Such numbers denoted by lambda or mu or whatever you like, as you wish. I denoted a number lambda between a and b such that the definite integral value is f of this number lambda. That is, in your integrand fx, put this lambda in place of x, that multiplied by difference of the limits b minus a. So take any example. For example, this fx is x square. A is equal to 0, b is equal to 1. You can find easily lambda between a and b satisfying this right side. Now, I am giving an example for this result. This is a GATE question in 2009 asked. If phi of x is equal to 0 to x square sine root t dt, then phi dash pi by 2 phi dash pi by 2 will be dash. Sorry. Now solution. What is phi dash x? Before phi dash pi by 2, we should find phi dash x. That is d by dx of phi of x. That is d by dx of phi of x given 0 to x square sine root t dt. Just compare this function with f of t, this 0 with the lower limit u of x, and this x square comparing with upper limit v of x. Then compare this result. So you will be getting, first in place of t, substitute upper limit x square. You will be getting sine root over x square into d by dx of v of x, that is x square, minus substitute lower limit 0 in place of t. You will be getting sine root 0 into d by dx of 0. So x square derivative 2x, sine root x square is sine x. So 2x sine x, and the remaining term is 0. Here this is difficult to integrate or time consuming. So for that they are asking phi dash x, but x is equal to pi by 2. Therefore, phi dash pi by 2 is equal to 2 into pi by 2 into sine pi by 2. Sine 91, 2 cancel. Simply this is pi answer. Okay, we'll go to standard integrals, that is formulas. Integral constant dx, k is a constant. Just like here, there also. Constant into x plus c, indefinite integrations. Integral x raised to n dx is equal to x raised to n plus 1 upon n plus 1. If n not equal to minus 1, generally denominator not equal to 0. Suppose n is equal to minus 1, this will become 1 upon x. 1 upon x integration is log x. That I have written here. Similarly, x power n into log x. So, this is replaced by all of you. A typing mistake. X power n raised to log x dx is equal to this question asked in 2013 and 2018 based on this. X power n log x is equal to x to the power n plus 1 by n plus 1 into log x minus 1 upon n plus 1, just like as above, n not equal to minus 1. Constant into any x term integration, if they ask, just constant will as it easily multiply after integration to x terms. Next, sin x integration minus cos x. When any, that means if x is multiplying by any constant, you should divide that constant after integration, but in differentiation, you should multiply the constant. So cos integration plus sin x by a. Secant square ax integration is tan ax by a. Cosecant square ax integration is minus cot ax divided by a. Integral 1 by root over a square minus x square dx is equal to sin inverse x upon a plus c. Integral 1 by a square plus x square dx is equal to 1 by a tan inverse of x by a plus c. This is hyperbolic function. Sin hx is nothing but e to the power x minus e to the power minus x whole divided by 2. Cos hx is nothing but e to the power x plus e to the power minus x whole divided by 2. So sin hx integration is cos hx. Cos hx integration sin hx. Now this is very, very important. Integral f dash x by fx dx is equal to log fx. So these are called, from this one, these are called methods of integration. So whenever in your integrand, numerator some x terms, denominator some other x terms, when denominator differentiation is belongs to numerator, that is f dash x, then immediately log of fx, where fx is the denominator. So for example, integral tan x. Tan x, here denominator is 1. 1 derivative is 0, but already numerator is tan x. So better to express in simpler terms. Before tan, what are the simpler trigonometric terms? Sin and cos. So sin x by cos x. Then I kept 1 minus outside and inside minus, minus and minus plus. Why should I do like this? Because I want to denote cos x, the denominator is fx. Cos x derivative is minus sin x. So minus sin x is f dash x. So it looks in the form of f dash x by fx. So minus outside minus minus log of cos x. According to the properties of logarithm, this minus shifted to the power. So cos x whole power minus 1 is 1 upon cos x, which is nothing but secant x. So log secant x or minus log cos x. Okay. This is another formula. When denominator, it is not example. The numerator just like as above f dash x, but denominator is under square root fx. Answer is twice the denominator. That is twice the root fx plus c. So this question asked in 2016. Integral dx by root over 1 minus x. It is with limits 0 to 1. So I want to denote this 1 minus x by fx. 1 minus x derivative with respect to x is minus 1. Minus is not there in the numerator. So outside minus, inside minus, minus into minus plus. So this minus 1 is want to denote by f dash x. Now it looks like integral f dash x by root fx between the limits 0 to 1. So it is 2 root fx. Outside already minus is there. So between the limits, whenever there are limits, then you can drop the constant c, ignore the constant c. Okay, so this simplifies to plus 2. So whenever you are given problem compared to these standard integrals and methods, so it is either 1 mark or 2 marks, no problem. So some other methods, if a given problem is not applicable by this page, these methods, then integration by parts, substitution method, etc. See. First, I want to do example substitution method. Please underline. Also called change of variable. That is, your question is x variable. It is changing to, as you wish, either t variable or u variable. What is exactly substitution method? So one of the term, one of the given x term, if you take t, the other x term is going to become its derivative. So for example, if you take x square is equal to t, what is x square derivative 2x? The other 2x dx becomes dt. So this is an example asked in 2017. I can write this is e to the power minus x into e to the power minus e to the power minus x dx. since a power m plus n is equal to a power m into a power n. So I want to denote this power exponential minus e power minus x is a t variable. So that is called substitution. Put minus e to the power minus x is equal to t. Differentiate both sides. So e raised to minus x derivative is minus into e raised to minus x. That minus this minus becomes plus. So e raised to minus x dx is equal to dt. So after differentiation, both sides you should multiply derivative of the corresponding variable. That is, left side is x variable, so dx you should multiply. Right side is t variable, you should multiply dt. So coming back to this, e power t simply dt. E power t integration is e power t constant of integration because there are no limits. So back to your original variable, t is nothing but minus e raised to minus x plus c. Okay, now this is one more method, very, very important, integration by parts. VBI means very, very important. So it is also called product rule differentiation. Now here product rule integration, that is whenever integration is under product of two terms, that is product of two x terms, one is fx, other is gx. Some people denoted by one is u function, other is v function. So there is a proper rule to select u function, v function, that is given by ILATE, or some people LIATE. No problem, both are correct. LIATE. Just these both are almost same, except in the case of L and I, where I stands for inverse function, sine inverse x, etc. L stands for logarithm function, log x, log of x plus 1, etc. A stands for algebraic, x plus 1, 1 by x, x square minus 2x, etc. T stands for trigonometric terms, cos x, secant x, tan x, etc. E stands for exponential function, that is e raised to x, 2 to the power x, etc. So, in the above stated order, the function on the left is considered as fx or u. Automatically, the other function is gx or v. So, what exactly this rule? The first function related to differentiation, the second function related to integration. So, fx into integral gx dx minus integral f dash x into integral gx dx. Okay. Some people doing or comparing by this method also. This is 12th standard method. Integral u dv is equal to uv minus integral v du. See, for example, x log x dx. This problem, this example, I can compare the previous standard integrals x power n log x. If you forget that formula, then this by part will be helpful very much. So log stands for L letter, x stands for a letter, that is polynomial function. So which comes what? Which letter? Sorry. Which function comes first? Log x, L letter, x algebraic letter. According to this, L is first. The next one is a. So according to this is u, and this is v function. Okay. Now what exactly? This is nothing but f of x, and this is nothing but g of x. So fx, that is log x, integral x dx, x integration with respect to x is x square by 2 minus integral of f dash x, log x derivative with respect to x is 1 upon x into x integration with respect to gx integration, that is x square by 2. So this is x square by 2 log x minus x cancel, take out 1 by 2 x dx is equal to x square by 2 log x minus x square by 4 plus c. You can compare this example by this formula, second formula, x power n log x, by putting n is equal to 1. Now, whenever u is a polynomial function, x plus 1, x square, x cube, and v is a trigonometric sine or cos or exponential function, Bernoulli is a scientist. He has invented the one-step answer, that is all these integration by parts by one-step procedure. For example, x cube into sin x. If you apply x cube into sin x, so this integration by parts, you will be getting at least half page, 6 to 7 lines. 3 times you should do integration by parts. But Bernoulli done the procedure by one step. That's why that procedure he has named Bernoulli rule. Some people that this is instead of Bernoulli rule, it is called general rule of integration by parts. What exactly this? Integral uv dx is equal to u into v1 minus u dash into v2 plus u double dash v3 minus u triple dash v4 plus etc. Dashes are increased by 1. Suffixes are also increased by 1. The dashes or primes stands for number of times for differentiation. Suffixes stands for number of times for integration. So, for example, suffix 2, that is 2 times of integration. Double dash, that is 2 times of differentiation. So, this is the procedure I already explained. Continue where it ends. This etc. means don't think that it is infinite terms. Somewhere it will end, somewhere it is terminating. So, whenever derivative of u becomes constant, what is the meaning of derivative of u becomes constant means either u dash or u double dash or u triple dash. That is first derivative of u or second derivative of u or third derivative of u. Somewhere it becomes constant, then stop. Because the next step, derivative of a constant is 0. So let us have an example. I have already done. Integral x square into cos x dx. This question asked in 2014. With the limits 0 to pi, but I have considered indefinite integration. X square related to algebraic terms, that is polynomial terms. Cos x related to trigonometry. So cos x is t letter, x square is a letter. According to I let, a comes first, t later. So this is u function, this is v function. So what exactly I am explaining here? First u into v1, that is first time integration of v. Cos x integration is sin x minus u dash x square derivative 2x into v2. Second integration of cos x, that is sin x integration is minus cos x. U double dash, that is 2x derivative, that is plus 2. And this integration minus cos x integration minus sin x. So why I am writing for every product of terms pair of brackets? It is for understanding easily. Okay. So that I have shown as above. So these are the methods of integration. If any given problem is not applicable by the above standard integrals and f dash x by fx or substitution method or integration method, some problems by partial fractions also, that is very easy case. If everything is failures, that is not applicable, then properties of different integrals. Take care. 4 properties. The first one is integral minus a to a f of x dx. Limits. See. Okay. Before these properties, we'll do 2 examples, then we will come back to properties. Otherwise, at a time, if I explain, you may feel difficult or confused. See. This is a gate question. The question is, the integral 1 by 2 pi, integral 0 to 2 pi, sine of x minus p cos x dx equals p is constant. See, it's a rare case your answer may not be matched with the given options. If all options are not matched with your answer, then everyone gets full marks. Okay. So, this is an x term, this is an x term, integrating with respect to x. Product of 2 x terms. Either you apply integration by parts, provided that is applicable. Somewhere it becomes constant. Here, none of the sine term, cos x terms after any times of differentiation, any number of differentiation will not become constant. So I can use the help of trigonometric formulas, that is transformations, 2 sin A cos B, etc. Okay, 2 sin A cos B is equal to sin A plus B plus sin A minus B. Using this, so given integral changes to, that is implies multiplying by 2, dividing by 2. So 1 by 4 pi integral 0 to 2 pi 2 sin x minus b into cos x dx. So this is angle A comparing with, and this x is b. So 1 by 4 pi integral 0 to 2 pi 2 sin A cos B sin A plus B x minus P plus x 2x minus B plus sin A minus B x minus P minus x x cancel minus B. Both terms integrating with respect to x. So 1 by 4 pi sin x integration minus cos x. X means here 2x minus B. Because this is integration, you should divide by x coefficient 2. Sin minus is minus sin, but it is a constant. Constant integration is constant into x. So this is between the limits 0 to 2 pi. So 1 by 4 pi into minus 1 by 2 into, first put x is equal to upper limit, that is 2 pi, becomes cos 4 pi minus p, lower limit minus, put x is equal to 0, cos minus p and minus sin p multiplied by 2 pi minus 0, 2 pi. So cos 360 minus theta is cos theta, fourth quadrant cos positive. Here 720 degrees minus theta, double time complete rotation. So this is nothing but 1 by 4 pi minus half into cos 2n pi minus theta is cos theta only. Cos theta. So this is cos p minus cos minus theta is plus cos theta, cos p, and that is minus 2 pi sin p. So this becomes cancelled and the remaining 2 pi cancelled. So minus sin p by 2. Here no option is matching. So everyone gets full marks for this type of problem. Okay, next example. This is a gate question. Given a real valued continuous function. What is real valued function? Means both domain and range. That is, when it is real function, both domain and range are real numbers, codomain and domain. Real valued function means codomain is a range. Codomain is real numbers. So defined over closed interval 0, 1. The question is limit t tends to 0, 1 upon t, integral 0 to t f of x dx. So this is limit and integration, two applications problems. Okay, two topics, limits as well as integration. So this is integration under limits. Now the question is limit t tends to 0. I can write this is integral 0 to t f of x dx in the numerator and denominator is t. So if I put t is equal to 0, this upper limit 0, whenever in definite integral limits are same, then that definite integral value is 0. So numerator is 0. In the denominator, if I put t0, that is also 0. So this becomes, according to limits, in the last class we had discussed 0 by 0 form. Then according to L'Hospital's rule, limit t tends to 0, differentiate numerator as well as denominator with respect to t. Here t is a variable. So this is d by dt of integral 0 to d f of x dx divided by d by dt of t. Since L'Hospital's rule. So this is equal to limit t tends to 0. This is by just first fundamental of theorem of integral calculus. In place of x, we have t. In place of t, we have x. So this is numerator is directly f of t. And derivative of t with respect to t is 1. So this is approaches to f of 0. Accordingly, answer is option D. Sorry. D by dx of integral a to x f of t dt is equal to just f of x. Replace the upper limit in place of t. Here, interchanging t and x, you will get this one. See. Properties of definite integrals. Integral minus a to a f of x dx. Limits are same but opposite in signature, opposite in signs. Okay. Is equal to two cases. One answer is 0. In the case of your integrand, that is f of x is odd function. If f of x is even function, then the given integral is twice integral 0 to a f of x dx. How do you prove or say the given function fx is odd function or even function? In the given function fx, put minus x. Put x is equal to minus x. That is, x is replaced by minus x. So you will be getting the new function f of minus x. Simplify. If you get minus into given function fx, then the given function is odd function. If you get plus into given function fx, then the given function is even function. Okay. See, f of x is equal to mod x k constant x square cos x cos hx are even functions. F of x is equal to sin x sin hx x comma x cube x power 5, odd powers of x. These are the simple examples of odd functions. Okay, now let us start an example. Let me explain second property. So whenever the limits 0 to 2a, here limits minus a to a, the distance between minus a and a is 2a. Similarly, the distance between 0 and 2 is 2a. Same type of structure, but limits are different. That's why answer is same in both results, either 0 or 2 times of 0 to f of x dx. On verifying the condition, this is take care. Earlier minus x. So your integrand is fx. X is replaced by upper limit minus x. That is, in your function fx, x is replaced by 2a minus x. 2a is the upper limit. You will be getting the new function f of 2a minus x. Simplify. If you get minus fx or if you get plus fx, proceed as above. Okay. So, substitution method I already told you. It looks like 0 to 2a f of x property 2. I want to do by change of variable, that is substitution method. Let me check my assumption is correct or not. X minus pi is equal to t. X is equal to t plus pi. Change of limits. As x lower limit 0 implies t is equal to, here if you put 0, t lower limit is minus pi. X upper limit is 2 pi implies here 2 pi minus pi. So t upper limit is pi. So t limits are minus pi to pi. Therefore, given integral becomes integral minus pi to pi. X minus pi is t. So t cube cos of 180 plus t. That is pi means 180 degrees. 180 plus t is third quadrant. In third quadrant, cos is negative. So this simplifies to minus pi to pi t cube cos t. Now I want to denote this product of two t terms, that is t cube cos t by f of t. So let me check whether it is odd or even, because the limits are in the structure of minus a to a. So put t is equal to minus t, that is minus t whole cube into cos of minus t. This is minus t cube. Cos minus theta is plus cos theta. So finally you will be getting this is function with minus of f of t. So f of t is odd function. If odd function, answer is 0, since by property 1. You can apply the same problem f of 2a minus x also. We can also apply property 2. Okay. And the third one, whenever a given integral is not applicable after the failure of the previous methods and these two properties, then apply this one. This is your question, integral a to b f of x dx. Now your answer is the same limits integral a to b, but x is replaced by sum of the limits minus x. No change if x is replaced by sum of the limits minus x. Please take care. Okay. Actually, it is not looking like any formula, but how it works, and it is useful very much. Let us go to an example. This one. So this looks like minus a to a. You can cross check this integrand f of x, that cos x by 1 plus e for x is odd function or even function. If it is applicable, then apply property 1. Otherwise, apply the property 3. So whether you all remembered in 12th standard, our teachers explained, that is some problems by using that property 3 starts with I is equal to given integral, that is minus pi to pi cos x divided by 1 plus e to the power x dx. Let us say this is 1, implies I is equal to, so your fx is here integrand this is f of x. So is equal to integral minus pi to pi, wherever x, it is should be replaced by a plus b minus x, where a is lower limit minus pi, b is upper limit pi. So minus pi plus pi minus x whole divided by 1 plus e to the power minus pi plus pi minus x dx. Since by property 3, so this entire term is f of a plus b minus x. A is minus pi, b is pi. Now this simplifies to minus pi to pi integration. Minus pi plus pi cancel. Cos minus theta is cos theta. That is, you will be getting cos x. Denominator 1 plus e to the power minus x. So this is equal to e power minus x. I can write 1 upon e power x. By taking LCM e power x, that second denominator shifting into numerator. So minus pi to plus pi e power x divided by 1 plus e power x into cos x. So this is I. Let us denote this is equation 2. So when you have two i's, just like 12th standard, adding 1 and 2, whether you all remembered or not. So adding 1 and 2, we get left side I plus I, left plus left side, right side plus right side, integration with limits same. So add the corresponding x terms in both 1 and 2 same denominators. So just add the numerators. So cos x plus e power x cos x, I can take cos x common into 1 plus e power x dx. So these two cancelled. Simply you will be getting minus pi to pi cos x. So cos x simple integration, or you can apply again odd even function. Cos x is even function. So 2 into 0 to pi cos x dx. This is even function. So cos x integration is sin x. Between the limits 0 to pi, pre-multiply by 2, sin 0, 0, sin pi 0. So this is 0. So 2i is equal to 0 means, therefore, I is equal to 0. I means given integration. Now see, one more property, that is 0 to pi by 2. Limits compulsory 0 to pi by 2. Either sine terms or cos terms. The powers are natural numbers. It is especially useful for more than 1. That is m is equal to 2, 3, 4, etc. Sine square x or sine power 10x or cos power 8x, etc. So the power is either even power or odd power. If m is even or m is odd, what would it mean? Same procedure. It is product of fractions where the first fraction whose numerator is 1 less from the given power, that is m minus 1, whose denominator is the given power. There onwards, every numerator and denominator are successively obtained by subtracting 2. That is, here subtract 2, m minus 3, subtract 2, m minus 5, etc. Here the first denominator is m, subtract 2, m minus 2. Next subtract 2, getting m minus 4. When should you stop? Till to get 1 upon 2. When you get 1 upon 2, you should multiply by pi by 2. Please remember that this will happen when the power is even. That is, see, even means, even power means 2, 4, 6, 8, etc. This is the last fraction. Definitely you will be getting 1 by 2. And you should remember to multiply pi by 2. For example, if I take 4, m value 4. So first numerator is 4 minus 1, 3 divided by 4, 3 by 4. Next subtracting 2 from numerator and denominator, 1 by 2, like this. Now if it is odd, the same procedure, the last term it has end with 2 by 3. Then you can multiply by 1. So if in the problem sine and cos terms both exist and they are in product, that is sine square x into cos power 4 or sine cube x into cos power 7x, etc. But the limits are same like this, 0 to pi by 2. Now, just like as above, First, apply the above procedure for sine terms, sine power, that is m minus 1. There onward subtracting 2 continuously till to get 2r1. When you take any natural number, generally, subtract 2 continuously, somewhere it ends either number 2 or 1. Similarly, the applicable for cos power, that is n, the first numerator is n minus 1, there onward subtract 2 successively, it will end either 2 or 1. The first denominator, when they are in product, just like logarithm, add the powers, that is m plus n is the first denominator, subtracting 2 successively, either it ends 2 or 1. All these terms multiplied by k. What is this k? Just like as above, in the case of even, you should multiply by pi by 2. Here both powers are even, then only multiply by pi by 2, that is k value pi by 2. Here already k is multiplying. Otherwise 1, that will come under this here 2 by 3 to 1. Okay. So let us have an examples on all this. Already 4 problems done. Please, at a time, at a glance, please remember thoroughly in this order 4 results. Not required to remember order also. Sorry. Okay. Area problem I already told you. This one. The area usually denoted by some people capital or A, bounded by the curve y is equal to fx. This is one boundary curve. That is your integral. X-axis. This is another boundary, lower boundary. And 2 vertical lines, left boundary and right boundary. Vertical lines means geometrically x is equal to 1, x is equal to 2, x is equal to minus 1. Just I drawn the diagram in the first quadrant. The shaded part is area. Is given by integral a to b f of x dx, where f of x is nothing but y. Interchanging x and y, you will be getting the area bounded between y is equal to a, y is equal to b, and y axis, and x is equal to function of. Similarly, area bounded between 2 curves. Upper curve is y is equal to fx, lower curve is y is equal to x. Again, 2 boundaries, that is 2 standing lines, 2 vertical lines, x is equal to a, x is equal to b, is given by integration, difference of the 2 function, where fx greater than or equal to dx. Usually this fx is called upper curve. And this is lower curve. Okay. We'll go to practice questions. The first one, modulus properties. Mod AB is equal to mod A multiplied with mod B. Similarly, mod A by B is mod A by mod B. Now, this can be written as x into cos x. Modulus of product of the functions can be written as product of their modulus. So that is integral 0 to pi mod x multiplied with mod cos x. You know that mod x definition is equal to plus x if x greater than 0, minus x if x less than 0, 0 if x is equal to 0. So 0 to pi means first and second quadrant, that is pi value approximately 3.14. So x value greater than 0. This is greater than 0. So mod eliminates, it will give x as it is. But I can't say cos x is positive or not. So let us know the trigonometry. Cos x is positive in the first quadrant, that is 0 to pi by 2. Second quadrant means 90 degrees to 190, that is pi by 2 to pi. Cos x is negative. So according to the definite integral properties, that is integral a to b is equal to integral a to c plus integral c to b. So here I am writing integral a to b is equal to integral a to c plus integral c to b if the lower limit a less than the breaking term c, break journey, that is See, A is origin, B is your destination. Between origin and destination, if you want to halt somewhere, that is a break journey, that is called. So A to C, C to B, that is. So 0 to pi by 2 x times mod cos x dx plus pi by 2 to pi again x mod cos x. Now the first quadrant cos x is plus v means positive. In the second quadrant cos x is negative. So this is 0 to pi by 2 x times cos x dx, and this is minus pi by 2 to pi x times cos x dx. Now according to integration by parts, this is algebraic u and this is trigonometric v as same. So u into v1, that is cos x integration, suffix means integration, minus u dash x derivative is 1, v2, that is sin x, one more integration minus cos x. Between the limits 0 to pi by 2. The other one is with minus only difference. The same terms you will be getting, that is x into sin x minus 1 into minus cos x. Between the limits pi by 2 to pi. So here sin 91, but here if I put x0, this lower limit giving 0. So upper limit simplifies to pi by 2 minus 0. Minus in minus plus cos pi by 2 0, cos 0 1. So minus of, if you put pi sin pi 0 minus sin 91, so this is pi by 2. Minus in minus plus cos pi minus 1, cos 90 0. So this is minus 1. Here plus 1 cancel, plus pi by 2 plus pi by 2 pi. So the answer is pi. Accordingly, answer is option C. Coming to second problem. I want to denote this is by fx. Let me check my guessing is correct or not, because the limits are looks like in the form of minus a to a integral. Check whether this integrand fx is odd function or even function. So f of minus x. Put x is equal to minus x. That is minus x whole square into log of ln means natural logarithm, basic logarithm. So 1 minus x divided by 1 plus x. According to logarithm of properties, if you inverse the fraction, it should be pre-multiplied by minus. So minus x square log of, I can write 1 plus x by 1 minus x. Since log a by b is equal to minus log b by a. So this is nothing but minus f of x. So that means this is odd function. So answer is 0. Since property 1. In the third solution, let I is equal to 0 to pi x sin x, just by using property 3, 1 plus cos square x dx, implies I is equal to x is replaced by sum of the limits minus x, that is a plus b minus x, that is pi plus 0, 0 plus pi minus x. So pi minus x into sin pi minus x divided by 1 plus cos square pi minus x. Pi minus x is 180 minus theta, that is second quadrant. Second quadrant sin positive, cos negative. So this is pi minus x into sin x divided by 1 plus cos square x. Cos pi minus x is minus cos x, but there is a square. I can write cos square x. So finally, this implies I is equal to, separate the numerator terms with the denominator, take the pi constant outside, 0 to pi sin x divided by 1 plus cos square x dx minus 0 to pi x sin x divided by 1 plus cos square x dx. So this is nothing but again I, the given problem. So minus I shifting into the left side will become 2i is equal to pi times integral 0 to pi sin x divided by 1 plus cos square x dx. So how to evaluate this type of integrations? Put cos x is equal to t, cos x differentiation minus sin x dx is equal to dt, and change of limits. X lower limit 0, cos 0 value 1, so t is 1, x upper limit is pi, implies cos pi minus 1, so t is minus 1. So t limits 1 to minus 1. If you change interchange of limits, the integration will affect by minus sign. That minus and this minus adjusted as plus. So therefore 2i is equal to integral minus 1 to 1 1 by 1 plus t square dt. So this is again even function because the limits looks like minus a to a. So 2 into 0 to 1, 1 by 1 plus t square dt. Both sides cancel 2. You will be getting left side I and right side 1 by 1 plus x square integration tan inverse x. But here tan inverse t between the limits 0 to 1. So substitute t1, tan inverse 1, tan 45 is 1. So upper limit simplifies to minus, plus pi by 4, tan 0, 0. So lower limit term after that simplifies to 0. So pi by 4. So therefore, I given integral value pi by 4. Tan 45 1, tan 0 0. So accordingly, answer is option B. Option A, sorry. So this is fourth example, the value of integral 0 to 2 pi sine power 6x. But limit should be 0 to pi by 2, but here 0 to 2 pi. If you want to apply property 4. Okay, so integral 0 to 2 pi sine power 6 dt. So just this entire function denoted by f of t. So this I can write 2 into 0 to pi by 2 sine power 6 t dt. Why? Because since in that t is replaced by upper limit 2a, that means 2 pi minus t. So sine 2 pi minus t whole to the power 6. 360 minus theta fourth quadrant means sine negative, but the power is even power. So simplifies to sine power 60. So which is nothing but function of t. Since by property 2. Why again you will be getting multiplication by 2? See this property. Yes, this one. If f of 2a minus x is equal to f of x, then 2 times of 0 to f of x dx. And again you can find, so that is First time you will be getting 2 times 0 to pi sine power 6t dt. So this is no change, that is f of t. Now the upper limit in place of 2 pi, it is pi. I want to check again pi minus t. That is t is replaced by pi minus t. Upper limit pi minus t whole power 6. 180 minus theta, second quadrant, sign is positive. You will be getting directly sine power 60. That is 2 times. 2 times it is applicable by property 2. Now this is 0 to pi by 2 sine power mt. So 4 times m is equal to 6 even power 5 by 6 m minus 1 by m. So there onwards every numerator and denominator successfully subtracting 2. So 3 by 4 and 1 by 2. If you get 1 by 2 multiplied by pi by 2 will occur in even case, since m is equal to 6 is even and by using property 4. So 4 cancel. 3 ones are 3 twos are 6. So 5 pi by 8. So accordingly, this is option C. So finally, area related problem. R and theta are nothing but polar coordinates. So x is equal to r cos theta, y is equal to r sin theta. If r is equal to generally over x square plus y square, theta is equal to tan inverse y by x. So therefore r is equal to a implies r square is equal to, I can write a square, implies x square plus y square is equal to a square. Let us say this is equation 1. Circle with center at origin 0 0 and radius is equal to a. Now r is equal to 2a cos theta, which is nothing but 2a into x by r, which is nothing but simplifies to x square plus r square is equal to 2x. R square value x square plus y square minus 2x. Again, this is also already given Cartesian coordinate circle having center minus g comma minus f according to 12th standard circles procedure. So center at a0 and radius here root over g square plus f square minus c. So now solving 1 and 2. Okay, that is, this is 1 in polar coordinate, this is 2 in polar coordinate. Cartesian coordinates also 1 and 2. We get cos theta is equal to 1 by 2 implies theta is equal to cos 60 pi by 3. Theta means tan inverse y by x. So tan 60 root 3, this simplifies to y is equal to root 3x. So from put equation 3 in 1, because we have to find x limits to find the area after I already converted into Cartesian coordinates. X square plus y square becomes 3x square is equal to a square. So 4x square, x square is equal to a square by 4, which implies x is equal to a by 2 plus or minus a by 2, of course. So from 3 comma y is equal to root 3a by 2. So therefore P is equal to point of intersection a by 2 comma root 3a by 2 is a point of intersection. Another point of intersection is there. I don't like that. I don't need that other point of intersection. My assumption is correct or not. So I will draw the circles. y-axis, x-axis. So this is center origin. Let us take radius A. And another circle having center at A0. So this is the common part, the shaded part. This is point P, one of the point of intersection X, origin Y. So this is equation 1. This curve is equation 2. Just 1 minute. Okay. So this is the shaded part, required area. Is required area which is symmetrical about that x-axis. So 2 times. So this is a breaking. This line, if I extend, which is nothing but x is equal to the corresponding p coordinate is a by 2. So 0 to a by 2. So before the vertical line, blue color vertical line, left side, the corresponding red color curve is corresponds to equation 2. In equation 2, what is that? This is. So 2 can be written as, after adding a square, subtracting a square, that is x minus a whole square plus y square is equal to a square. From this, y value root over a square minus of x minus a whole square. So this is a square minus of x minus a whole square dx plus the shaded part after the standing line, vertical line, x is equal to a2, that is a by 2 to a, because this is 0 to a. Okay, this point is a radius. Okay, so this red color curve corresponds to equation 1. From equation 1, if I find y value root over a square minus x, why should I find y value? Because when you have x limits, the area bounded by the curve is integral a to b y dx, that is f of x dx. So root over, so it is bounded between 2 curves. Now I am writing a formula, integral root over a square minus x square dx is equal to x by 2 root over a square minus x square plus a square by 2 sine inverse x by a. This is the formula you have to use in both. In place of x, we have x minus a. So just I am writing the formula in 1 minute. So x by 2, that is x minus a by 2 root over a square minus x square means x minus a whole square plus a square by 2 into sine inverse x by a. In place of x, we have x minus a. So these terms between the limits 0 to a by 2 plus, that is originally given, x by 2 root over a square minus x square plus a square by 2 sine inverse x by a between the limits 0 to a, and main square bracket simplifies. So this simplifies to, you will be getting two a square, sine inverse 1 is pi by 2, sine inverse 1 by 2 is pi by 6, sine 30, pi by 6, 30 degrees, sine 30 1 by 2. So 2a square into pi by 3 minus root 3 by 4. Please check. So this is approximately 1.228 a square. So accordingly, answer is option D. This is a very difficult problem. So thank you for everyone. Please subscribe the channel GATEFORUM, providing various courses like live session, internet classes, that is e-gate, for every stream. More number of hours they are giving, every topic, every concept, every definition with example, gate questions they are discussing, and refresher course, that is already looks like typed material concept along with examples, and 2010 to 2020 all GATE question solutions explained. Next, test series. There are 3 types of tests. One is chapter wise, otherwise subject wise. Other one is just like GATE pattern, the complete syllabus test, GATE level, that is called target tests. Okay, don't miss the chance. In the upcoming weeks, we are having some other mathematics subtopics classes, engineering mathematics classes, followed by technical subjects. Thank you for attending the classes. Please subscribe the channel for getting more videos. Thank you once again. So I'm closing the session. Bye bye. Good night.